So I'm Yotam. I'm a manager. I manage the operations for the SAP Development Experience Group. We're going to talk about how we're building a CI for 50 teams. So first, a quick mandatory slide about what is SAP. So SAP is a very large company, about I think 80,000 and something employees. It's a software company. Here you can see that about 70-something% of the world's revenue transactions somehow go through SAP systems. We can also see that 98 of the Fortune 100 or something of the sort companies use SAP. They are SAP customers, and we had 2 years ago we had over 2 billion euros of cloud subscriptions of revenue for cloud subscriptions and support. So a bit about us, our group. First of all, what we do. We deliver a product called SAP Web IDE. It's a cloud-based, web-based IDE. Just see the IDE in your browser. And it's a development environment for building SAP applications. In Israel, we are about 100 employees in this department. We create a platform for SAP Web IDE. But we also have, we are about 8 or 9 teams, I think, don't remember. But we also have about somewhere between 40 and 50 contributing teams all across the globe, Vietnam, Vancouver, wherever. That are contributing plugins to the Web IDE. And also we deliver Web IDE to 2 major platforms. One is the cloud-based platform that I just mentioned, and the other is an on-premise installation that some of our customers can install. Our focus is, well, it was on JavaScript development, pure client-side development, and now we're now we're going into full-stack development that is also compiled on the server. It's a large-scale operation. So some history. When we first started, we had about 4 Windows Server VMs. We managed them manually. We ran about 200 unit tests with a success rate that was totally random, about 25% from what we measured. And the feedback loop we gave to the developers was somewhere between 16 and 24 minutes. Also, sometimes very random length. And we did everything manually. We configured the VMs manually. We configured the jobs manually. Everything was manual. What we currently have, and this is our major flow for the teams in Israel, we have about somewhere between 200 and 300 Linux VMs. We manage them using Chef, and we use Docker images to simplify our flows. We have over 5,000 tests with a success rate of between 80 and 90%. Most of the failures are random test failures when the test is written badly. The feedback loop is, sorry, pop up here. The feedback, come on, okay. Okay, the feedback loop is about 5 to 9 minutes, depends on the test's length. We manage that in off-cycle. Talk about that later. And the configuration is almost entirely automatic. We use job DSL and Jenkins pipeline to create our jobs. We don't create jobs manually anymore. So now I'll show a short demo of what most of our teams are doing. Probably can't see my screen. I'll shut off the slides. Can you see the command line? Okay, good. Okay. So I'll just create a dummy commit. Allow empty. It's I'm just creating an empty commit, and then I'll go back to the browser in just a few seconds. I'm pushing this to Gerrit. We use Gerrit now. Now, we always did. Yeah, this should be okay. Okay, so what I did, I created an empty commit, and now, okay, we have network. And now we can see my change, which has nothing in it except the commit message in Gerrit. This is a code review system, which we also use with some hooks to trigger Jenkins. Now, what we see here, and I'll zoom in a bit. I'm sorry, this is also not my computer. My computer did not like this network for some reason. So I'm improvising a bit. So what we have here, we have a multi-job that is generated with about 32 tests, test suites that we run. We run them in parallel, each on a separate VM inside a Docker container. This flow that I'm showing is for our client-side code. So what we do is we use Karma, and we run that inside our container with Chrome. We also have some linting tools and so on. Again, this takes somewhere between 6 and 9 minutes, depends on the test length. And what we did here is we said that if your tests take longer than 10 minutes, then you should just split them into another VM. It's kind of simple to do that. It's not too much work to create a new test suite and have it automatically added to the Gerrit trigger. What we also have, once this is done, the developer gets feedback here in the Gerrit page. Allowing the developer to submit their change and merge it back to the master branch or whichever branch they need. What we also have, we have another multi-job, a bit simplifying it, but we have another multi-job which runs Selenium tests. We run this every hour. For all the teams, they're all working on one repository, and about 8 or 9 teams, 8 from Israel and another one in Germany. And we just split the test and said, okay, let's run 34 Selenium test suites in parallel on top of our application, and we run this every hour. This actually never really worked well for us. I'll go back to the presentation. Okay, so this never actually worked well for us because some of these tests are unstable, and keeping them stable is work. It's sometimes even lots of work. So yeah, our developers work on stabilizing their tests all the time, but since we're talking about 100 people, most of them are developers. I think about 70 or 80 are developers. Something always breaks, and once stuff begins breaking, people usually tend to think it was the other team. Someone else's fault, probably not my change caused it, and then they start neglecting the tests. And we really quickly reached a situation where the tests are always broken. So what we did is, yeah, I see some people nodding. What we did is, even more people. What we did is we implemented a bad thing, but it was our only solution to this problem. We implemented code freezes. We blocked merging changes when these test suites fail for 3 or 4 times straight. It means I mean, for after 3 or 4 hours that the tests started failing, we block merging, which is bad because the whole point was enabling the developers and helping them work faster. But we had to do it in order to keep our test suite running and green all the time. Here you can see some screenshots of code freeze implemented, code freeze fixed, and we're kind of in a bad place right now. We have code freeze about half the time, probably something like that, which is really bad. We also send out some statistics regarding this. You can see it on the right hand. This test suite succeeded 80% of the time, which is marked as red, and the other test suite succeeded 95% of the time, and that is not marked with any special color. So the developer needs to know that, developers can know that they need to stabilize their tests. I'll tell you a secret. Only some developers really take this mail seriously. Most of them just have it go to their spam. I started talking about our scalability issues. So as our test suite grows, we just get less stability and less stability and less stability. Even at times where we get more engagement from developers, we see the success rate fall. Sometimes it's due to real errors, that real bugs can be found with tests, who knew? But sometimes it's just badly written tests and lack of attention. I began this lecture with mentioning that we have about somewhere between 40 and 50 teams contributing to WebID, contributing plugins. Now, they don't work on our central repository. They each have their own repository. They each have their own CI solution. I don't really know, but I'm guessing that most of them use Jenkins. You know what? All those that I asked said that they use Jenkins, but they implement their own Jenkins solution. They need to maintain it. They need to maintain their jobs. They need to think how their CI flow should look like, and that's lots of work, lots of maintenance. And the last thing, or last major issue we have is maintainability. We mentioned earlier we have 200 to 300 VMs. As we grow, we need more and more VMs, and even when we started using Docker and started using Chef and all that magic, which really helped, but it's still a lot of maintenance work. So here's what we are currently doing. We are creating a new CI flow, new CI infrastructure, which is based on these concepts. The first one is the microservice approach, which basically says that we will split WebID into several smaller components. Not really microservices. All these components still run in the same browser tab, in the same frame, but we want better separation, better componentization. And we want the components to be independent of changes in other components, in other unrelated components. So I won't have to run tests for other components when I push changes to my code. The other thing is the maintenance costs, not in terms of money, but in terms of work, maintenance work. So we decided not to have a large Jenkins instance. It doesn't scale well. It can be done, but it's hard to do. And we want them to be, the smaller Jenkins instances, we want them to be easily reproducible. So if a Jenkins server suddenly dies or crashes, or we've all been there, so it's easy to reproduce. And we also wanted, since we want smaller Jenkins instances, we want a central pool of Jenkins agents, nodes, slaves, you pick it, that we maintain, and not dedicated nodes per Jenkins master. Third thing, we want the developers that are developing their component to take ownership of their CI, of their delivery. Currently, our team delivers the code to production, which is really, it's really just a waste. We don't really need to do that. So we want the developers to take ownership of their full life cycle, whether it's a CI, whether it's deployment to production, everything. And the last thing, we want to have the same tools, same mechanisms, the same infrastructure, same everything for contributors outside of Israel and the people working on WebIDE in Israel, the platform WebIDE team. So here's what we did. I'll describe a flow. The developer wants to write a new WebIDE plugin, so it goes to GitHub. We have an example repository which has a plugin that basically adds a button to WebIDE that says "Hello World." So that developer clones that repository. Or, of course, it can, the developer can also create that using WebIDE, but not the flow I'm going to show. We have a team in Germany that is working on something called Jenkins as a service. It's proprietary. It's inside the SAP network. But what they do is they let you, and we'll see that in a basically a click of a button, you just create a new Jenkins instance. They run it using Kubernetes on some VMs, which are maintained by our IT team. So everyone basically can just go to their administration screen, click on a few buttons, and get a new Jenkins instance. It only takes a few minutes. We have our slaves also maintained by them using the Kubernetes cluster. We'll see that in a moment. But basically, it means that we have one pool that any Jenkins master can access and get slaves from. We use Artifactory to download the Docker images that we supply centrally, and we also have a Jenkins-based release server, also managed in Germany. So now we will see a short demo. Okay. Okay. So first of all, this is the example repository I mentioned earlier. I will just fork it to this organization. It just takes a few seconds. And while this gets done, here it's done. This is the Jenkins as a service administration screen. We can see that we have 2 Jenkins instances, and I can go here to Jenkins templates. Probably session timed out. Yes, just a second. Okay, these are the Jenkins templates that are provided. Basically, these are extensions of the Jenkins Docker image, which is updated with every weekly, with every weekly release and every LTS release. So these are extensions of that. They also install some plugins, some proxy configurations, etc. So all I need to do is create a new instance, my instance, and I need to add my cost center so they would know who they should bill. I'm just writing here something, and I'll create it. So what this does, it just creates a new Jenkins instance. It takes a few minutes to load, so we'll see, we'll have one that I prepared earlier, and also gives us a Grafana installation that we currently do not use, but we will in the near future. Okay, so I'll go back to the repository we have. I'll just, oh, wait, first of all, oh, sorry. Okay, see that I'm still logged in, I'm logged in. Okay. Okay, So what we have here, we have a built-in job that basically all it does is just generate other jobs using the job DSL plugin. I think it's this organization, and okay. Okay, so now I see that we have two jobs that are generated. So now I will just create a new pull request. I will add a new file or something. Okay, and I will create a new pull request based on this file. And here we go. Okay. Once I created this pull request, we have Jenkins automatically run a build job for me. You can see it here. We use Blue Ocean because why not? It's just great. Sorry, the network here is not that quick. And this can take a few minutes. We'll get back to this. I will show you. No, not here. Here. We basically, on top of Jenkins, we basically give some other scripting and tools that can be used by the developer, whether it's a tool for bundling. We see here only 3 lines of code that enables the user to bundle or package or minify their plugin, so it would take only 1 request or something of the sort, instead of sometimes we saw hundreds. This is really important for web performance. And we also have tools for testing for Karma. Okay, now we can see that that we started this flow. Okay. We can see Blue Ocean. It runs parallel stuff. We can see that it runs linting. We can see that it runs Karma tests, and it runs a build for bundling, and so it will also be deployable. How is this actually done? So we can see here, most important part is the Jenkins file. We have a pipeline library that we supply our users. We'll see that in a few seconds. And here, Kubernetes comes into play. We can define a Kubernetes pod, which basically allocates something similar to a VM to the users. And in that pod, we tell Jenkins to start up a few Docker images. The first one is the JNLP image, which basically, once it's up, it tells Jenkins, hey, I'm here, you can use me. The other images are basically our supplied image, and we run it 3 times. We'll see why in a second. And now we have our pipeline. We say, okay, inside the node called CI pod, in parallel, we run Karma, ESLint, and our build. So we can see that for Karma, we first check out our code and run a simple shell script. Sorry, run a simple shell script and then add the test results to the job. That's just the way that pipeline works. For the other things, for the linting and the building, we just using the pipeline library, we just have a simple function called ESLint, and then it knows just to lint my code for me. We have another one called build MTA. MTA is our deployable archive. So we just give it a few parameters, and it runs the build for me. And of course, this is all done in parallel, as we can see in Blue Ocean. Hooray, it succeeded in a few minutes. So basically what we did is we accessed the Kubernetes pool, got a pod, it's called a pod there, and ran our tests and build code and linting inside of the containers we supplied. Okay, I'm running short on time. We also have other flows here that are pretty similar. We have 5 minutes. I'll try to sum things up. Basically, what we did is we created very simple, very automatic flows that are really the same for almost anybody. But we also enable the developers to break out of our templates. We consider this a template, and let's say someone wants to parallelize their tests even more because their test suite takes 10 minutes, but they want their build to run in 5 minutes. No problem, you can do that. It's your Jenkins file, have fun with it. So the maintenance of Jenkins itself, of the Kubernetes slaves, is in this case, it's not done by us, but we're just lucky that way. But again, it can be done in a centralized way, but enabling the developers. Everything is automatic, so no problem if a Jenkins instance crashes. And I think that's it. Any questions? Go ahead. Someone with a microphone? Okay, I'll just repeat the question.
Can you explain more detail why you moved from centralized Jenkins server to the Jenkins proposal?
Yes, okay, several reasons. One is that large Jenkins instances are hard to maintain. They require, of course. The question was why we decided to move from a large central Jenkins instance to several small ones. So first, the central Jenkins image, a very large Jenkins image, or Jenkins instance, is hard to maintain. It's a single point of failure for the entire organization. Usually requires lots and lots of RAM. Our central Jenkins image right now has, I think, 128 gigabytes of RAM, and it still is very slow. And maybe even the most important part, we don't want to manage it. We don't want to manage the Jenkins instance for every development team. We want to give them that power or that responsibility, which is a better word. This sometimes can be hard because some teams don't know how to manage Jenkins, but since it's a very small usually it's very small use cases, so they don't really need to know that much. So it becomes somewhat of a non-issue. It is an issue, I won't lie, but not that big of an issue. In a perfect world, I would like even more decentralized approach where the developer doesn't even know what the Jenkins instance looks like. Something similar to what Travis and Circle CI and all those services are doing. But we'll see if we can get there. Maybe Jenkins will get there first. Anyone else?
Great. Thank you, Yotam. We have to continue with the next lightning talk.
Okay.
With the next talk. Okay. So any questions you can ask Yotam afterwards. But I really want to thank you about this talk.
Thank you.